Okay, welcome to Algorithms and Flowcharts, Lesson 3. So, last week we looked at how we use variables within a program, which in other words is an area of memory with a given name, and how we then keep track of what's going on in that variable or part of memory when we're running our program. And we run our programs in our heads, if you like, or we by tracing the flowcharts and just keeping track of what's going on in that particular part of memory. So, for example, in this one here, we have an algorithm that reads in a value of a from the user, and a is basically the variable name, so we assign that letter to that area of memory, that bit of memory, and then the user will type in something. Now, if the user types in Joe, then Joe will get stored in variable A in that bit of memory. So when we get to the next part of the program which says print A, it will take whatever's in that box, whatever's in memory location or variable A, and it will output it to a screen as part of that print. So it will actually just print out Joe on the screen, and then the program will terminate. Now, if we were to describe this algorithm in English, we would say it takes input from the user and prints that input onto the screen. So when we get to the next few algorithms and flowcharts, I want you to try to see if you can have an idea or try and work out in English what it is that the program actually does. So try to describe the algorithm in a single sentence in English. That's the task. Okay, so let's have a look at the next one then. So this algorithm here, and what we'll do is we'll go through it step by step, and then we'll work out hopefully what this algorithm actually does. So from start we have print, enter a number from 0 to 9. So print means put it out on the screen over here. So we're going to have it just say print a number from 0 to 9, excuse my writing. And then it will take the input from the user via the keyboard by putting this read in, and it will read it into this variable called value. So I've got an area of memory here called val. So as it says up here, we're going to actually type in and press the digit 6. So in our value, it will have 6 in there. Now, the next part of the process, or the algorithm, says print value. So on the new line over here on our screen, it's going to just put 6 because that's what it's got stored in value. Now, the next operation is val equals val plus 3. So what that means is we're going to do this bit here, take whatever's in val, add 3 to it, so 6 plus 3 is 9, and then we're going to write that, going to put it into val, which is this one here. So we get rid of 6 and we replace it with 9. So 9 is now stored in that memory location. So next part of the algorithm, is val greater than 20? No, 9 is not greater than 20, so we go around and print val again. So we're now putting 9 in there. Then we go through this again, val equals val plus 3, so in other words 9 plus 3 becomes 12. So in our memory we replace the 9 with 12. Is it greater than 20? No. Go around again, print the value onto the screen, 12. Then we go to value equals val plus 3, so it becomes 15. Is it greater than 20? No. Go around again. So, oops, cross that out. So then we replace that and then put 15 on the screen for the print value. Add 3 to it again. It now becomes 18. Is it greater than 20? No. Go print it on the screen. And then we add 3 again. So it becomes 21. So now we're here. We've just added 3. We go, is value greater than 20? Yes, it is. So print end of program on the screen. So over on the screen, we put end of prog. And then we terminate or finish the actual program. Okay, so effectively this algorithm will take a number and keep adding 3 to it until it reaches 20. And that's it. That's what the algorithm does. And it outputs that result on screen. Okay, next one. Now, I'm going to just have a look at managing these variables and doing operations with them. And you'll, again, try to predict what this algorithm does in English. So from the start, we read in A. So if the user inputs the value of 5, then it says print A times 2. So on our screen, it's simply going to print whatever this is multiplied by 2. So it's going to output 10. So from there, the program finishes. Now, another example of that might be, let's see if we can just wipe this out a second. Another example of that might be that the user inputs Joe. Again, now when we get down to here, print a times by 2, what you see here is it's not possible to multiply Joe by 2 because Joe is a word, and what would happen is the program would crash. So we don't want that, and we will find out later on ways to go about preventing that from happening. But for the moment, we're just going to assume that the user knows what they're doing and they type in 2 or 4 or whatever number they're going to use. Okay, so this algorithm just takes whatever number is entered and doubles it, and that's our description in English of the algorithm. Okay, next one. We've got 2 variables this time, very similar to the previous one. It reads in a value A, so let's say the user types in a value of 2, and then it says B equals A multiplied by 2. So we take whatever's in A, multiply it by 2, and we put it into this variable B. So 2 multiplied by 2 is 4. And then on the screen, we will output whatever is stored in variable B. So it's going to be 4. So if the user were to put something different in, let's say they were to put 201 in there, then B multiplied by 2 would become 402. Oops, pen's going dodgy. And then on the screen it will print out 402 because that's what's stored in B. Okay. Next algorithm. So that algorithm in English, if you can try to think about what it does, it simply takes user input number and outputs double whatever the user has input. Okay. So this one, we input our first number and we read that into variable A. So let's put a number in. Let's call this I don't know, let's say 7. Oops, 7. Okay, then we input a second number and read that into variable B. Let's call it 5. Then in variable C, we will store whatever A plus B is. So we add whatever's in A to whatever's in B, in this case 7 and 5 together to make 12. And then we output whatever is stored in this memory location, this variable C, which in this case is 12. So on screen we output 12. So in English, this algorithm simply takes 2 numbers from the user and outputs the sum total of those 2 numbers. Okay, this one's a bit more tricky. First input number. So in other words, we might put the same numbers again. 7, input second number, 5, and then we have a question. Is A greater than B? Is whatever's in A, which is 7, greater than whatever's in B, which is 5? Yes, 7 is greater than 5, so we're going to print 7 on the screen. Okay, so what happens if that wasn't the case? Let's say we'd put 3 in A when we go through this again. 3 is in A, 5 is in B. Is A, in other words 3, greater than 5? No, so we will print whatever's stored in B, which is 5. So in English, this algorithm will print out the higher of the 2 numbers that are entered by the user. Okay, almost finished. So same again, input 2 numbers. First number goes into A and the second number goes into B. So if we have 7 and 5, we now have a situation where we have taken into account a situation that wasn't catered for last time, because we could only output A or B. So now you'll see that A is 7. Is A greater than B? Yes, so we'll print 7. And in the previous situation, when we had 3 in here, we didn't say no, A is not greater than B. So beforehand we just printed out whatever was in B. This time we ask an additional question. Is B greater than A? Yes, B, so still print 5. So what's this extra bit for? Well, some of you will have been spot on and noticed that if you put in 2 numbers that are exactly the same, the previous algorithm just output 5 no matter what, or whatever number had been put in, the two same numbers. This one is a little bit cleverer, and it will take into account the fact that A is not bigger than B, because 5 is not bigger than 5, and B, is it bigger than A? No, 5 is not bigger than 5. So in this case, we're going to output on the screen numbers are equal. So this one just has a little bit of extra dimension to it to say, right, I can also work out if these two numbers are equal rather than just work out which one's the biggest. So it's a slightly more sophisticated algorithm. Okay, so your task now is to try and do something similar to what we've just done, but now try to take 3 inputs and get your algorithm to tell us which is the largest number of the 3 inputs.